Many different pieces of equipment, like pumps, compressors, and fans, are essential to the operation of an industrial facility. But before this equipment can operate, it must be supplied with power. Electric motors are among the most common means of supplying power to drive equipment. But other drivers, such as internal combustion engines, gas turbines, and steam turbines, are used in various applications. During the course of your training, you'll be learning about all these different types of drivers. For now, we're going to focus on steam turbines. Making sure that the turbines in a facility are working properly is an important operator responsibility. If the turbines aren't functioning properly, the driven equipment can't perform the work that must be done to keep the facility running smoothly. For example, this steam turbine drives a feed pump for a boiler that supplies steam to many different processes in the facility. If this turbine were to fail, it could affect not only the operation of the boiler it supplies, but all the different processes using the steam from the boiler as well. For reasons like this, it's important that operators understand how steam turbines work and how to keep them operating properly. In this program, we'll concentrate on the basic information you'll need to operate your turbine safely and efficiently. Let's start by looking at what a steam turbine does. Essentially, a steam turbine converts the energy contained in steam into mechanical energy that can be used to drive rotating equipment. We'll use a simple illustration to show the basic principles of turbine operation. The process is a lot like steam blowing on a fan's blades and making the blades turn. The steam first passes through a restriction called a nozzle. The purpose of the nozzle is to convert the steam's pressure into velocity. You see, as the steam passes through the nozzle, it speeds up. The faster moving steam then strikes a set of blades, causing them to turn. And the turning blades produce mechanical energy that can be used to drive rotating equipment. The blades used in steam turbines are a little different from the simple fan blades we just saw. Let's take a look at some typical turbine blades and see how they do their job. Generally, turbines use a series of fixed and moving blades to make the most effective use of the steam's energy and cause rotary motion. The blades shown here are designed for what is called impulse movement. Basically, impulse means that the high-velocity steam pushes on the blades and causes the blades and the shaft they're mounted on to rotate. We'll take a closer look at how impulse movement works in a moment. Turbines also have blading that does not rotate. There are a series of fixed or stationary blades here, attached inside the bottom half of the casing. Both kinds of blading, fixed and moving, work together to accomplish the energy conversion that takes place in the turbine. This example shows the blading arrangement in a typical small turbine. Two sets of moving blades are included on one wheel that is attached to the turbine shaft. The fixed blades here are located between the two sets of moving blades. Now, to get an idea of the flow path of steam through this arrangement and explain how this flow path causes movement, we'll use this illustration. In our illustration, the shrouding or rim that holds the blading together has been removed so we can see the shape of the blades. These are the moving blades, and these are the fixed ones. The steam flows through the first set of moving blades where some energy is extracted. From here, the steam flow is routed on to the fixed blading. The fixed blading then redirects the flow of steam to the next set of moving blades so that more energy can be extracted from the steam. Once the steam has passed through the second set of moving blades, the steam is routed out of the turbine. This flow path of steam striking the moving blades causes the moving blades and the turbine shaft they're mounted on to rotate. The energy in the steam decreases as it is converted to rotational force. So the steam now contains much less energy than it did when it entered the turbine. The arrangement of blading we just saw is typically referred to as a single-stage turbine. Like the example you see here, single stage simply means that a series of fixed blades is used together with one or two sets of moving blades. In this program, we'll be focusing on turbines similar to this one. There are other turbines that are called multi-stage turbines. In these turbines, a stage refers to one set of fixed plus one set of moving blades. Well, we've covered some important basic concepts for steam turbines. We've talked about what a steam turbine is and about the principles of how a steam turbine converts the energy contained in steam into a rotational force. These concepts are the basis for all phases of steam turbine operation. So before you go on, review your text and make sure you understand the material that we've just discussed. Then, when you return, we'll take a look at some of the basic components of the turbine itself.